Good morning, happy almost Thanksgiving to everybody. Kimball High School still in the football playoffs, so we're going to say good luck to everybody on that account, and hopefully we'll have another football game after we come back from the holidays. But anyway, wanting you to take just a little bit of an investigation into what's coming down the pipe when you come back from the holidays. So we're going to start to investigate the next function. We've spent a lot of time on quadratic functions, y equals x squared to the second power, and we're going to begin to study the other function that is related to that. Now you'll notice that right here I've got a geomirror, and I'm going to tell you what we're going to do with that in just a minute, but it's good for drawing reflections. And so what we are going to do is I want you to reflect this graph, this parabola, these parabolas that you have on your paper over this line, the line y equals x. And the way we're going to do that is I'm going to show you how we're going to make that reflection. And I also want you to make that reflection in a different color than what is printed on your paper. This is black and white, so this parabola is going to be in black. So make your reflection either in a different colored ink, or if you've got a colored pencil or a marker, go ahead and do it like that. So the first step, your step one on these problems, is you want to reflect that parabola over the line y equals x. And so I'm going to rotate my picture around just so you can get an idea of what I'm going to do. And I'm rotating it upside down just so I can see what the reflection is going to look like. And then I'm going to take my mirror and I'm going to put it down on my paper so that I get a real good idea of what this particular point looks like. And so you cannot really see me doing this part of it as far as what I'm looking at, but I'm looking, just so you know, I'm looking on this side of the mirror and I'm seeing a reflection of the graph. And so when I see the reflection of the graph, that gives me a point right here. And that gives me a point down here. And that gave me two other points right here. So the best way to do your reflection is go ahead and find 5 points and then put your 5 points on the graph and then go ahead and make that reflection. And so when I flip everything back over, my reflection is going to look something like that. So I've done my reflection. Now, you got some questions here to answer. And number one is you need to create a table of values for my reflection. Well, a table of values for my reflection, I'm going to have 0 and 0, 1 and positive 1, 1 and negative 1. I'm going to have 4 and 2, 4 and negative 2. Now what you're going to find is when you do your reflections is you're going to have similar patterns like this, but the numbers might be a little bit different. Now when I get to these questions right here for A, B, C, and D, state the domain of my of y equals x squared, and let me go ahead and color in what my y equals x squared was. Y equals x squared was this part in red. My reflection of y equals x squared was in blue. But when it says state the domain of y equals x squared, I'm looking at the numbers. These arrows tell me that the domain of y equals x squared is going to be all real numbers. So I'm going to say D, and I'm going to say all reals for that part where it says state the domain. Now on this second part, it says state the domain of the reflection. And so now I'm looking at the x values only. State the domain of the reflection over the line y equals x. Well, I'm only looking at the x values. How far to the left does x go? Can anybody tell me? That's right. It only for this graph right here, x only goes back to the origin. So the domain of my reflection is, and this is how you might want to write it. This is one way for you to write it. X is greater than or equal to 0, because x can be 0 or it can be anything that's positive, but on my reflection it didn't have anything right here. Okay? Now, when it says state the range of y equals x squared, okay? The range is only the y value. So we're looking up and down, up and down. How far down does the graph go? Okay, the graph only goes down to 0 and then it goes back up again. So my range is going to be y is greater than or equal to 0. And then finally, the last question says, state the range of the reflection, y equals x squared over the line y equals x. Well, my range is y values, and you can see that my y values are on top and on bottom, and these arrows mean they go on forever and hit every value. So the range of my reflection is all real. So we would say all real numbers. Okay? And the last thing that I want to let you know is there is a connection between the domain and the ranges for these two figures. And if you look at what it says, right? The domain of y equals x squared is all real numbers. The range of my reflection is all real numbers. Okay? The domain of my reflection was x was greater than or equal to 0, and the range of my original graph, y equals x squared, was y was greater than or equal to 0. So what I'm wanting you to see when you do this reflection, and this is going to be a type of function we're going to work with when we come back from the holidays, there is a connection between their domain and their ranges. And we'll talk a little more about what that function is, but I want you to explore this. So on your paper, you have a problem on the front and on the back. And what I want you to do is I want you to reflect the parabola over the line y equals x, and then I want you to answer those questions.